All right, example 3. Here we have a square root making an appearance. So this is no longer a rational expression because we have something that's irrational, the square root function. So the technique here, well, first let's not get too far ahead of ourselves. First step is always to just plug in the value. So in this case, we're going to be plugging in 9, and we're going to get 0 in the top and, unsurprisingly, 0 in the bottom. So now this is a context clue that we should do some algebra, some sort of technique to help rewrite this. So in the case of something containing a square root, it's often useful to rationalize the portion of the expression that has the square root. You may remember back in middle school or high school that if you had an expression like 2 over the square root of 3, you could rationalize the denominator by multiplying by, in this context, root 3 over root 3. In which case you get 2 root 3, and the bottom, root 3 times root 3 is 3. Effectively, you just moved the square root to the top in some equivalent manner. So in this case, we can do that using the conjugate. There's another method here of factoring canceling. So I'm going to go ahead and do method 1 of rationalizing via the conjugate, and method 2 by factoring and canceling. So let's take a look at method 1 here. So we're going to rationalize the denominator. So in this case, let's just pick up where we left off. So we have the limit of 9 minus t over 3 minus root t. So we're going to multiply this by the conjugate of the denominator. So the conjugate here, we just change the sign in the middle. So 3 minus root t turns into 3 plus root t. And remember that math, when you multiply by something like a fraction where the top and the bottom are the same, then really what the numeric value of what's inside this box is just equal to 1. And remember that multiplying by 1, that doesn't change the expression. Multiplying by 1 never changes anything. That's why multiplying by this is legal, because we're not actually changing anything. So what I do at this stage now is notice that the bottom is the denominator here is what we're trying to rationalize. It was the portion that had the square root. So because of that, I'm going to go ahead and FOIL out the denominator, but I'm not going to FOIL out the top. I'm going to leave the top just as written as 2 factors next to each other. I'm not going to bother FOILing that all out. But I will go ahead and FOIL the denominator. So this would end up being 3 minus, it's not 3, excuse me, this would be 9 minus t if we FOIL it all out. It's a difference of squares. We can then cancel that. And what's left over is just the limit as t goes to 9 of 3 plus root t. So again, you are more than welcome to rewrite it and then in another step take the limit, or we can just take the limit right now, which is going to be 3 plus the square root of 9, so 3 plus 3, which is 6. Method 2 here, we're going to factor and cancel, which oftentimes I think this method 2 is faster than the rationalization method. But not everyone sees that this thing can factor. To no fault of your own, it was sort of beaten into you in algebra that you factor something until you, right? If you start with something that's a quadratic, you know, you might be able to factor this down into something where you've got 2 t's to the first power. Or if you have a cubic, you might be able to write this as some quadratic times a linear thing. Or maybe 3 linear things multiplied together, right? You always go from whatever power you started with, maybe 14, and you might be able to factor it down until you have things raised to the first power. So you always are trained to stop at the first power. But That doesn't have to happen. You can keep factoring as much as you want to. It might not be useful, it might look ugly, but it's certainly algebraically valid. So for instance, 9 minus t, this is 3 plus square root of t, 3 minus the square root of t. This is a difference of squares. You are trained to find things like x squared minus 16 and say, okay, this is a perfect square, 16 is a perfect square, right? So we can factor this into x plus 4 and x minus 4. Well, t is just the square root of t squared. So you could really, anytime you've got subtraction between two things, you can definitely use the special factoring form of difference of squares. Now, what it factors into, a lot of people might think this looks uglier than this. And that's true, I think. But you have to think about what's your purpose. What are you trying to do? What are you trying to accomplish? Well, in this case, noticing that this 3 minus root t is a factor of this, if we do this uglier factoring, then we can cancel it away. So the goal here isn't to make something look aesthetically beautiful, it's rather to simplify things. And because we can simplify that one factor by cancellation, this is definitely a good method to use. So with this in mind, we can write the limit as t goes to 9. We can factor the numerator into that difference of squares. And then we can just cancel. And then we can evaluate this to get 3 plus the square root of 9, so 3 plus 3, which is 6. So if you're good at seeing those, it can be much faster.